Hello and welcome to my channel. I am the Mad Computer Scientist, and here we discuss mathematics and computer science topics that interest me. Today we're going to talk about the FOIL method. If you saw one of my earlier methods about the box method for multiplying polynomials, this is just another way of doing the same thing. We're going to go over the steps of the FOIL method and try to get some visual cues to help you to understand what's going on. But before we do that, I'd like you to take a second, if you are new here, to hit the like button and the subscribe button and ring that notification bell if you have not already. If you find this content useful, please be sure to leave a comment down below. If you have any topics you would like me to cover, please leave that in the comments section as well. We use the FOIL method when we have two binomials that look something like what we have on the screen here. In this case, we have x plus 3 times x plus 3, both in parentheses. Now we're going to multiply the expression in the previous slide using the method I have mentioned. To use the FOIL method, we have to understand that it's an acronym. Each letter stands for a different step. F stands for first, O stands for outer, I stands for inner, and L stands for last. This acronym stands for the steps we're going to do this in. So we're going to go through the F step, or the first terms in the binomial. I have put them in black to help you identify which terms we're going to multiply. In this case, we're multiplying x times x, which, as you know, will give us what's on the following slide. As you can see, that will give us x squared. After we have multiplied the first terms, we can go to the O and multiply the outer terms. And again, these outer terms are in black so you can see what we're multiplying together. In this case, we have x times 3, which will give us x squared plus 3x, and we have two terms we haven't figured out yet. Once we have gone through the outer terms, we now go on to the I step and multiply the inner terms. And once again, we have 3 times x, which will give us so far x squared plus 3x plus an unknown term. Now that we've multiplied the first outer and inner terms, we can do the L step and multiply the last terms. And this will be something like pulling the mask off of a Scooby-Doo villain at the end of an episode, where we can figure out what it's going to equal or close to it. In this case, we're multiplying 3 times 3, which you know from your basic arithmetic is 9. So that gives us the expression x squared plus 3x plus 9. You're probably wondering if we're done yet, and the answer is no, we are not. Unfortunately, math teachers like having things in the simplest possible forms, and what we can do here is combine like terms. Because we combine like terms, we can add the 3x and 3x together, which will give us the expression x squared plus 6x plus 9. And now we are done multiplying this binomial. But wait, Mad Computer Scientist, wasn't there an easier way to do that? For this particular problem, there was. If you notice that this fits into the binomial squares pattern, you can use that instead. The binomial squares pattern occurs when we have a binomial multiplied by itself, or we have it raised to the power of 2. In this case, the first term is going to be the first term squared, either the outer or inner terms multiplied together, and the product will be doubled, and the last term will be the last terms squared. This will make things a little easier in the future, and this can apply to both negative and positive binomials. But keep in mind, if you have a negative binomial, the middle term will be negative instead of positive. The last term in either case will be positive. If you've been following this channel for any length of time, which can't be too long because it's fairly new, you may notice that sometimes these end with some math fun or things I think might be fun for some people. So in this case, we're going to take a number m and we have another number n. We want to know if m is a power of n. Well, there's an easy way to do that. You take the log of m and divide it by the log of n. If the result is an integer, m is a power of n. Now, if you want to do this on a computer, it may not always work. For example, if you do the Python standard math library or Node.js's math library, sometimes you'll end up with a floating point number that is close to the result, but not exactly the result. However, if you use a precision library such as Python's NumPy, this should work. It should also work on most scientific calculators. By the way, it does not matter which base logarithm you use. This will work for any number. The formula I've provided is also how you convert to one base of a logarithm to another base of a logarithm. That's it for this video, everyone. Remember to like, comment, and subscribe, and as always, have a good day.